Hi, my name is Austin Cawley Edwards. I'm a senior software engineer at FinTech Studios. Today I'll be talking about running Flink inside of a startup environment and specifically how we do that with the Ververica platform and a custom Kubernetes operator. So I'll talk about FinTech Studios and who we are and how we started using Flink. I'll also talk about the Ververica platform and why we built a custom operator for it. I'll also talk about our Flink deployment lifecycle at FinTech Studios with Helm, GitLab, and what that CI/CD system looks like, as well as a demo of deploying and rolling back, and then kind of where we've come and where we'd like to go. So at FinTech Studios, we provide news, analytics, and business workflows for the financial industry, covering 40 languages and millions of sources. The documents that we process range from structured documents to RSS feeds to PDFs and things like web scrapes. You name it, we can ingest it. So we process around 1 million documents a day, all with Apache Flink. An example use case would be a legal and regulatory change manager that's monitoring hundreds of different regulators across the world. And if they don't respond to something, their company is fined enormously. So what our platform does is really tags these documents in a granular way using a structured taxonomy and lets them know exactly what they need to care about. So for us, Flink was a really easy fit from the start as a use case. We have streaming data of these documents coming in, and we really wanted to leverage the power of it on Hadoop and Yarn, as that was the hosted solution we found at the time. But it proved too resource intensive for us as a startup. We didn't use Hadoop in any other of our applications, so finding that modern tooling and getting the CI/CD set up for it was just too much work for our small team at the time. So observability also suffered because we really couldn't figure out how to stream logs with Hadoop. We were SSHing into the cluster and manually uploading artifacts that way. So we also built our own rather poor deployment system. So we never really made it to production with that. And we kind of tabled Flink for a little bit. Recently, we had the ability to, or had the opportunity to replace a Node.js streaming application that handles the normalization, enrichment, and tagging of our documents with a few Flink jobs. So we were really after a platform that provided a good computational base for other applications at FinTech Studios, as well as something that we could automate in the CI/CD space. So we found Ververica and Kubernetes as perfect candidates for that. And I'll get into a little bit more about how we implemented that solution. But Flink now enhances and protects our core data streams. And using things like the async IO for NLP and NER tagging has really gotten us some dependable data pipelines. So I'm going to go into a quick demo of our platform just to give you a little bit of context about what we do, but then I'll talk about the operator and how we use it. Apollo is FinTech Studios' platform for news and business analytics, specifically for the financial industry. But like I was saying, we can ingest any kind of unstructured document. So what I really like to do is ingest the Flink mailing list, which we do for the dev mailing list, the English user mailing list, and the Chinese mailing list. I'm really interested in the Python support, which we have a tag for, so I can filter down to just those emails regarding Python. And I'm also really interested in UDF support. We don't have a tag for UDF, but we can do just a raw text search and get down to exactly what we care about. We also offer in-app translation, so I can finally read those Chinese emails and understand what's going on in the entire Flink community. Like many other companies, we're also doing a response for the COVID-19 virus. So one of my favorite dashboards that we've built for that virus tracking specifically is by region, where I can compare what's going on in Asia to what's going on in the Middle East and how different industries are being affected. And this is all driven through aggregating news stories from millions of different sources around the world. The Ververica platform is a platform for deploying Apache Flink. It handles lifecycle management and upgrades, high availability. It has some nice web UIs and REST APIs. It also has other enterprise features that I won't get into, but plenty of them. It's built for Kubernetes and it's got a really great out-of-the-box experience. We use Enterprise, but are happy to see that the Community Edition was just released. And so getting into a custom operator, an operator in Kubernetes is just an application that runs inside Kubernetes to operate our system using the Kubernetes APIs, while itself also being managed by the APIs, the Kubernetes APIs. So one way to think about it is just encoding something that a human would do to operate a system. So one of the key benefits is to help unify the management of all these different systems within Kubernetes. And how they do this mostly is through custom resources to extend those Kubernetes APIs. So many of these operators, including ours, are open source. So you can check out a bunch of them. There's hundreds, thousands, tons. So like we said about the Ververica platform, it's really easy to use and gets great support out of the box. It's built for Kubernetes. It's got some great Kubernetes features like high availability without Zookeeper, manages SSL encryption between the job managers and task managers. But some of the things that we found lacking in the Kubernetes space was the ability to manage these Flink deployments natively. You have to either go through web UIs or some REST APIs. So CD is then done through HTTP requests to those REST APIs. We also found that changes to those REST APIs between versions of the Ververica platform created some friction because we needed to update all of our deployment specs when updating. And the changes aren't usually major, but it does require some updates if you're using some experimental features or things like that. So for the custom operator, we knew we had to interface with these REST APIs anyway, so it made sense to do that within Kubernetes. And we were able to do it in a way that has multi-version support to make it easier to migrate from the old versions of the Ververica platform without upgrading each one of your jobs immediately. This also allows us to have native management of these Flink jobs with tools like kubectl or kubectl, however you say it, and Helm. And integrates really nicely with Kubernetes events, which are a really great way to see what's going on exactly in your system. And the only con we kind of found was that we had to build it ourselves, but from a tech point of view, it was fun. So we were happy to do so. So what an operator kind of looks like is just an application that sits inside of Kubernetes. It sits here and listens for updates on the custom resources that we were talking about. So these custom resources are mapped to the Ververica platform resources, such as VP namespaces, deployment targets, deployments, and save points. So all of these things can be deployed as native Kubernetes objects, and whenever those objects change, our Ververica platform operator tries to synchronize that with the Ververica platform itself. So in this model, the Ververica platform is still in charge of booting these task managers and job managers, keeping track, doing upgrades, doing the high availability. So we get all of the benefit from using the Ververica platform without actually having to use the UI itself, even though it's nice. One of the other benefits that we get out of this is being able to deploy the application kind of all at once. With the CD system using an HTTP request, while the Ververica platform supports Kubernetes features like mounting config from config maps and secrets really well, it expects those to be done upfront or in a different deployment. So what we can do with our new Kubernetes custom resource is package that all at once. So our runtime config, secrets, and deployment all live in the same package that can be deployed and rolled back at the same time. And it also allows us to add other nice Kubernetes extensions like service monitors if you're monitoring with Prometheus to point at those task manager and job manager metrics. Another thing that we do is set up infrastructure for the Ververica platform. So they have a concept of namespaces, similarly manage the isolation and users, and deployment targets for which Kubernetes namespace to deploy into. So from the CI/CD overview in GitLab, it's a pretty standard system. We've got our building of the artifacts. We test the artifacts and then we push them up to S3. From there, we deploy directly into our development cluster through a Helm upgrade. This will push all of our resources into Kubernetes. The Ververica platform resources will get picked up by our operator, and the other resources like config maps and secrets get picked up by their controllers. And the operator synchronizes with the platform and tries to make that deployment happen. Another thing to note is that we have a manual Helm rollback job right here, so we can roll back immediately if something goes wrong, right from the same platform. And of course, if you're pushing to production, we also have the next stage after everything looks good in development, a manual job as well to synchronize that with the production cluster. So now we'll go into what that kind of looks like live and go from there. This is the view of the pipeline, like we saw in the slides earlier, where we have our build, test, release, and deploy stage. What we really care about right now is the deploy stage, where we have the deploy job for the top speed application and this manual rollback job that can be triggered if anything goes wrong right from the same UI. So I've already run this today just to make sure nothing funny happens for this demo, but I will rerun it now as well as show you the Kubernetes events that happen when we deploy. So if you're interested, you can take a look at what this job is doing in the CI definitions, but it's mainly just doing a Helm upgrade install. So you see as it gets deployed, all of the Kubernetes events start popping up. You'll see the VP deployment that we just looked at in GitHub piped through from the Ververica platform saying we need a state transition because we want to make this running. So you'll see all of the different things that go into deploying a job, from creating the different task managers and job managers to actually pulling down the artifacts. And as you'll see attached to this VP deployment, the job started successfully. So success. And what that looks like in the Ververica platform is very similar. If we're going to the top speed namespace, we'll see one running job, one running deployment with these same events. So if we hop back to GitHub, I've added this distance modifier feature, which is really cool. It will deploy right from GitLab in the same way as soon as I merge it to master, which I have. So I will do the same thing over here where we deploy that new feature that's made it into master right from this deploy job. So we can look at the side-by-side event log and CI job as well, just to see the same thing happen, but with this new exciting feature. Since this job is stateful, Ververica platform will take a save point before it upgrades it and start the new job with that old save point. So as you see, we're using an upgrade strategy and we're creating a save point before suspension. It looks like the save point was completed correctly and we are killing that old job, pulling down the new one, spinning up a new cluster, creating that new job, creating those new job and task managers, waiting for that job to start. So it looks like there's a back off and a general failure from the Ververica platform UI. So they're saying the containers aren't starting correctly. If this was production, I would not panic, but I would roll back pretty quickly. But since this is development, let's take a look at why that's going wrong. So if we take a look at the pods, we'll see that our job manager pod seems to be restarting quite frequently. So if we take a look at the logs, we get this nice stack trace. It looks like we can't initialize the cluster entry point Diving deeper, it looks like it originates from a number format exception where I'm trying to pass 4.0 to parse int, where 4.0 is a double. Silly me. So if we go back to the Kubernetes events, let's just roll that back because that's not going to be able to be recovered. We'll jump to our rollback job, trigger manual action. And what this will do is just run Helm rollback like you would in the command line. So if you're near a command line, by all means, do it faster by yourself. But it is available as soon as you deploy from the same platform, which just makes it easier and reduces the human error. So while this is rolling back, let's take a look at the Ververica platform UI and compare that to what we see in the Kubernetes events. So it looks like we're creating a new job and spinning up the cluster just the same. So as this job gets torn down, you'll start to see the pods getting killed and rescheduled, repulling those artifacts, restarting those old pods, and waiting for that last deployment to spin up. Now we're moving at top speed once again. So this is all done through the operator with those custom resources, but really is just interfacing with the Ververica platform, which does a great job at managing and upgrading. So from that time that we planned on going with the Ververica platform in Kubernetes, it's been 6 months. We've deployed 2 Kubernetes clusters and we've deployed 3 Flink jobs. So in that time, we've also built this Kubernetes operator, and we're fully managing our Kubernetes clusters with GitLab CI/CD, which we found really cost-effective and resource-effective from a team perspective. It doesn't take too much to maintain this. We've also had a seamless migration from that Node.js application to these new Flink jobs. It's provided much more clarity into how we're processing the data and given business a really a better look into what's going on under the covers. So what's next for us is trying to make the Ververica platform operator feature parity with the UI. There's certain things that you can do in the UI, like access the underlying jobs or the Flink UI, that would be great to incorporate into the Ververica platform operator. This might be possible with a little bit of a tighter integration with the Ververica platform itself, perhaps adding a few new REST APIs to access that lower level data. We'd also really love to see more upgrade patterns within the Ververica platform itself. They've done a great job at the stateful upgrades, and excited to see what else is possible. I was recently looking at the lift operator, one of the ones that was still in alpha when we were first considering this solution. And I know that they are on the way to having blue-green and some other types of upgrades. So one of the things that we would like to do is experiment with what else is out there that wasn't when we started this. I know there's a bunch of really cool ones for Flink and a thriving ecosystem there. So hoping to learn and check out more as the community grows. And lastly, I'd like to thank Ververica for being so flexible, putting on this virtual conference. They've been really great partners to work with so far. And that's kind of it from me. If you'd like to check out our operator, it's open source on GitHub. We're on Flink packages. Ask me questions, contribute, all welcome. The demo that I gave today is also open sourced on FinTech Studios GitHub, so please check that out if you're interested. And if you like what we do at FinTech Studios, check out our careers page, sign up for Apollo. The COVID dashboards are free while this is all happening. So from my house to yours, I hope you're safe, and thank you for watching. Bye.